So we want to again say good evening to everybody and welcome to our review of the December 5th snow event. I'm Joe Deli Carpini, the Science and Operations Officer for the National Weather Service in Boston Norton. And with me tonight, a couple of our regular presenters, Rodney Chai, one of our meteorologists, and Hayden Frank, one of our lead meteorologists who help put this event review together. So welcome to Rodney and Hayden. All right, so I'm going to get started, I think, with the first part about kind of what happened during this event. You may not quite remember because we're all kind of in storm mode now for the next one. This was a heavy rain and rain to snow event for much of the area and was, you can see this is a map of the liquid precipitation that fell across the region. And you can see, highest amounts fell east of kind of the Worcester Hills and into Rhode Island with a max actually over 3 inches here in southeastern Massachusetts. So with the ongoing drought conditions, these were actually very beneficial rains, and part of the reason why our drought conditions have been improving over the past few weeks. You can see less in the way of precipitation out in western Massachusetts and western Connecticut, but still, not too shabby for a fall event. And looking at the snowfall, this was mainly an event for the higher elevations. You can see, not much along the coast, an inch or two. And this was an area where our forecast was a little bit overdone, and Hayden and Rodney will get into that. We did hit our target area, though, the Worcester Hills, northern Connecticut Hills, and northwest Rhode Island. Most of this area received between about 6 and 12 inches. You can see Paxton there at about 12 and a half was kind of the maximum. And a little bit less once you get more further removed from the storm. Very little in the Connecticut River Valley along the I-91 corridor, and a little bit more where we had some elevation in the Berkshires. East Hawley, Mass. had about almost 4.5 inches of snow. So some of the impacts, there were power outages from this, but with the heavy wet snow being restricted to kind of the higher terrain, you can see pretty much focused in Worcester County. We had about 33,000 power outages that evening. Not a tremendous number, but you can certainly focused in the higher elevations of Worcester and even parts of Middlesex counties. Just to show you some nice scenic photos. Again, this is mainly in the higher terrain. This is from John Baggioni out in Burlington, Connecticut. You can see some nice snowfall there, a downed tree limb, of course, from the heavy wet nature of the snow. This is looking from our friend Brandon, looking in the Worcester Hills. Again, you can see it's primarily up on the higher terrain. Holden, Mass., our friends at the DPW there always like to share pictures. Kind of more of a scenic snowfall there. Hayden's house in Westboro is always, we always get pictures from Hayden. So this was taking a look in his yard, and you can see several inches of snow there. In Chelmsford, a little bit further in northeast Mass, you can see some, a little bit of snow, but again, heavy and wet in nature, taking down probably a weakened pine tree, it looks like there. And from Rodney, who's our resident snow bug, if you haven't figured that out already, he had sent out a tweet showing these large snowflakes in northeast Rhode Island. But again, we'll talk about some marginal temperatures that prevented some sticking. But in this case, it was heavy enough to overcome the warm surface and resulted in some snow-covered roads. So with that, I will pass it on. I believe this is Hayden's section on actually forecasting the storm. So Hayden, go ahead.
Actually, I think this part was going to go to Rodney.
Oh, my mistake.
And then I was going to, no worries.
Okay, Rodney, go right ahead.
No worries. But thanks, Joe and Hayden. Let's take a look at some of the thought process in forecasting the storm. And as Joe alluded to, the temperatures were very marginal. And basically, when you have marginal situations, everything kind of needs to come together almost in a perfect way. And one of the key things that we looked out for is the surface low track. And the two images that you are looking at are made by WPC, the Weather Prediction Center. And on the left, you can see the surface analysis of the surface low track kind of 12 hours apart from each other. So you can see that the surface low is actually a forecast to track a little bit further east, which is and take it closer to the benchmark. The 70 west, 40 degree north benchmark that we we like to use as a gauge of whether we can see accumulating snowfall along the I-95 corridor from Providence to Boston. So that was a trend in the right direction if you are a snow lover, because it makes it more likely that colder air will make it all the way to the coast and increase the chance for snow. And this is the surface analysis map, again made by WPC. And remember, the previous one that was a forecast, but this one is actually actual observation and actual in the past, meteorologists like to do this kind of surface maps by hand, but nowadays you can use the computer to help speed up the process. And what you're looking at is, you can see that the red numbers are temperature in Fahrenheit, the green numbers are dew point temperature, and you can see widespread 40s and 50-degree temperatures, and that basically shows a lack of cold air across the region. And fast forwarding to 7 a.m. on Saturday, you can see the surface low just off the New Jersey coast. Associated with it is the warm front, and you can see that kind of hard to see, but if you look below the temperature, you can see the two dots. That's light to moderate rainfall, and basically rain was falling over most of the region as the warm front lifts north. And so what you're seeing here is, basically one of the procedures that we use to analyze the atmosphere, and this is basically looking at the NAM temperature at different levels of the atmosphere. So going kind of from the top left, looking at 3,000 feet, and then we go down to 2,000 feet, and then so on and so forth, just to kind of get a gauge of are there any warm layers above freezing in the lowest 3,000 feet that could, result in mixed precipitation and, which would result in less snow at the surface. So this is this is NAM, one of the forecast temperature profile. And if you go to the next slide, you can see how the blue shading is further south and east, and kind of hard to see, but the blue shading, that's kind of the 0 degrees Celsius or 32 Fahrenheit line. And if you are in the blue zone, you are kind of in the colder region. And one thing I want to point out on the bottom left corner, that's the wet bulb temperature. And sometimes you may have heard of the term evaporative cooling. If the precipitation falls hard enough, you may start off at 40 degrees, but the temperature will crash if the rain falls hard enough and flip over to heavy snow. And that's actually one of our key considerations as we were forecasting the storm, because the temperatures were kind of too warm to begin with, but our analysis calls for a band of precipitation heavy enough to cool the atmosphere such that the rain will flip over to snow and cause issues associated with winter weather. So and if you look at this HREF, that's one of the high res models that we look at, kind of 48 hours out, and you can see that dark blue shading kind of stretching from Rhode Island to all the way into to Maine, and that's very classic signature of a mesosphere bending of snow, and that dark blue shading implies heavier snowfall rate that could result in reduced visibility and snow-covered roads. And this is looking at the probability of 12-hour snowfall exceeding 4 inches. And as meteorologists, we like to look at things in a probabilistic manner, especially when confidence is lower. And we kind of like to get to see, is there a higher chance of exceeding a certain threshold? In this case, you can see that dark red shading, that's actually over 90% probability of exceeding 4 inches of snow. So that's actually a pretty good signal, 24, 48 hours out. And there's even some very decent probability of snow exceeding 8 inches in 12 hours. So that would be a warning criteria snowfall. Because if you get 6 inches in 12 hours, that's a warning criteria, winter storm warning. And this is looking at hourly snowfall rate. You can see the green, light green shading that's over 1 inch per hour. That's pretty heavy snowfall. Snowfall rate exceeded, stretching from central Massachusetts to all the way to Boston. And this is the probability again of ensemble probability of exceeding 1 inch per hour snowfall rate. And you can see there's a kind of a zone of 70s, 80% probability of that heavy snowfall rate. So that again increases confidence. And there's even some probability of 2 inches per hour snowfall rate, kind of stretching from Metro West into Essex County. And this is looking at 12-hour snowfall, a probability match mean. So some of you may wonder what is probability match mean. So very simply speaking, it's a more skillful way of looking at taking the mean. And the href, it's really a combination of 5 models, across 2 time periods. So that would be basically 10 members. The probability match mean, basically, instead of just taking a straight average, you take the average, but you keep the amplitude. So you keep the extreme members, and in this case, so you kind of preserve the special characteristics of the different members better. So it's a more skillful way of looking at average. So in this case, you can see there's some indications of actually 12 to 18 inches of snow across Worcester County into northeast Connecticut. And this is the ensemble maximum. So that was previously the mean. This is kind of like the max. It's kind of like the worst case scenario. Some indications of up to 2 feet of snow, and actually close to a foot all the way into Boston. So that's all this basically increases our confidence of an impactful event. So now I'll pass it to Hayden, who's going to talk about messaging.
All right, great. Thank you, Rodney. So going into this event, as Rodney and Joe alluded to, the thermal profiles, as we call them, temperature profiles throughout the atmosphere, were quite marginal between rain and snow. So this was our first shot at the snowfall amounts several days before the event. And obviously, when we start to forecast an event, say that's 2.5, 3 days in the future, try to kind of give a broader scope. And you'll notice though that we kind of really were hitting early the Worcester Hills, the higher terrain of the Berkshires, as the areas that had the best chance of getting the most, and then the lower elevations like the Connecticut Valley and eastern Massachusetts coastal plain with the lower amounts. And as we move forward here, confidence the next 12 to 24 hours increase somewhat, and you'll see now we've brought heavier snowfall amounts further south, and you'll see there's 6 to 8 inches now for a good portion of north central and even interior northeast Massachusetts. 3 to 4 in Boston. We'll talk about that in a little bit here, and a couple through the Connecticut Valley. So confidence was growing. We usually try to start off a little on the conservative side, especially when temperatures are so marginal and things can go either way, and then kind of build on that. And as we move to the next forecast issuance, this was about 24 to 36 hours before the event. You can see how we start to refine things. You'll notice higher amounts focused in the Worcester Hills, but not too much change in eastern Massachusetts and into the Connecticut Valley. So we were kind of starting to see the real focus of this was going to be in the terrain, and you can see how we kind of brought the higher amounts into the northeast hills of Connecticut, and from that you can kind of see, well, this is really going to, the best chance of the higher amounts is going to be in the elevated areas, say above 800 feet, the Worcester Hills, the hills of northeast Connecticut, and even into the Berks. And as we move forward here, sometimes we like to throw these type of graphics out on social media. One of the things we were really focused on were the power outage risk, because we knew this was going to be a 32 to 33 degree snow, and you start to get 5, 6, 7, even 10 inches of that, you're going to have a lot of power outage. And in this case, we started to see like the Worcester Hills really highlighted from that. So once confidence increases, you'll often see we'll have a winter storm watch, and when we get more confident in that, we'll upgrade to a winter storm warning. And that's what we did with the next package. You can see, centered in the Worcester Hills, but going towards Springfield and Boston. Obviously, the edges of that warning did not work out. We'll talk about that in a little bit here. So this was our forecast, the early morning of the event. And as Rodney mentioned, the models started to come into better agreement in heavy snow, even into parts of eastern Massachusetts. What we were never sure about was the western extent of the heavy snow or rain, depending on what the precipitation type was. And the precipitation type would be rain or snow across eastern Massachusetts. Because of those high resolution models, we did beef up those snowfall totals. But unfortunately, it was a little warm at the ground, so a lot of that snow was unable to accumulate. And there were another couple processes at work, which we'll talk about as we move along here. So one of the things that may have gotten forgotten in this event were very strong winds along the coast. As Joe mentioned, we had the power outages in central Massachusetts into northeast Connecticut, mainly in the higher terrain. But we also had power outages from Essex County into Plymouth, into Cape, and that area where we had 55 to 65 mile per hour wind gusts. And actually, this part of the forecast worked out perfectly. There was damage, there was power outages. Most of the precipitation on the immediate coast was in the form of rain. But there were reasons that we were able to see the threat for these winds. And you'll see that when we kind of show the maps of the low pressure system. So one of the new products we have is it's called Potential Winter Storm Impacts. And this is available on our webpage. And what it does is it just doesn't take our snow accumulations. You could have, 10 inches of snow across the whole state. Well, if it's a wet snow in one area and a dry snow in another area, it's going to have vastly different impacts. You're not going to get power outages and tree damages with dry snow like you will with wet snow. Well, in this case, we knew that all the snow that fell was going to be wet. And where we had the higher amounts, the tool was able to pick up on where the greatest risk for power outages were. And this worked out perfectly. You could see the area highlighted from the Worcester Hills into part of the northeast Connecticut Hills. So to some of our partners, emergency managers, first responders to, those power outages, this is more useful than just a snowfall map, okay? Because they're able to focus on where the greatest risk is for damage, where they're going to focus their, say, utility crews. Well, a lot of times they're focused on the Cape and Islands because that's where we have the strongest winds. But in this case, the power outage concern was across the high terrain of central Massachusetts and into northeast Connecticut. So going into the mesoanalysis, and this is what we do is forecasters as an event gets underway. And this is a look at water vapor imagery. And where you see that spin in the atmosphere right off the Delmarva coast, that's where the low pressure is. You have what's called a counterclockwise spin around low pressure. So if you're to the east of the low, you can see how it's transporting a ton of moisture northward into southern New England, Massachusetts, Connecticut, all the way up into Maine. Now, this is a surface map, something you may see quite often on TV, and you'll see that L, low pressure system, and you'll see the pressure on it, 996 millibars or 29.41 inches of mercury at 7 a.m. Saturday. When we go to the next slide, 4 p.m., notice how much lower it is, 982 millibars or 29.00 inches. When you have a storm undergoing rapid intensification, that means it not only can produce heavy rain and or snow, but very strong winds. And one of the reasons that we actually did not get the snow we were expecting on the eastern Massachusetts coast was at the last minute, the storm track shifted ever so slightly to the west. Well, you may think, well, a 20, 30-mile shift to the west, does that really make a big difference? Well, in terms of meteorology, it does. Imagine the rain-snow line, instead of being 10 miles east of say, Worcester, it would be in Boston or vice versa. So in this case, that westward shift resulted in a lot more rain and less accumulating snow in eastern Massachusetts. And there you can see 7 p.m. Saturday, the low is lifting up into the Gulf of Maine. And usually we get into northwest flow once it lifts north of our region, and that's usually a drier flow of air. So that's kind of basic diagnosis of what we're looking at. If this storm had been 50, 75 miles further east, we would have been dealing with a significant snowstorm for most of the area. And this is a look at the radar imagery, and you've probably seen this a lot on TV. And you can obviously see there's greens, reds, but notice that dark red. It almost looks like thunderstorms south of Worcester into northeast Connecticut. Thunderstorms? Actually, no. And if we go to the next slide, we'll see it better. So this is something that we look at called correlation coefficient. And to make it sound less complex, basically, that is a product that highlights when you have different precipitation types of different sizes. So you have, say, melted snowflakes mixed with raindrops. That's where your precipitation differential line is, whether that's dividing between snow, rain, or sleet. That really tells us near time where it's snowing and where it's raining. And you can also see it on the reflectivity of the radar, because it'll look like thunderstorms, because the radar really reflects high back on melted snowflakes. It gives a real powerful return, and you can see that matches up in that correlation coefficient. And where you see those lower values, it means you have mixed precipitation types. That's right where your freezing line is. And another thing we tend to look at is thermal profiles. And when I say thermal profiles, I'm talking about temperature differential in the atmosphere. But we think of temperature differential at the surface. It's warm, it's cold. But what really drives significant rain and or snowstorms are tight thermal differential, temperature differential over small areas. And you can see this is looking about 5,000 feet off the ground. Look at how tight those temperature contours are packed. Well, you're having the atmosphere is kind of fighting, right? That's where you're going to get your significant rain and snow. That warm air is lifting up and over that colder air at the surface. Even though it wasn't that cold, relative to what this was above, it was. So that air is forced to go up and over. And that's where you get your rain or snow, depending on if it's cold enough. So looking at the forecast findings before we go into our next event, what did we learn from this? Well, we knew from the get-go, right up until the event, this was going to be an extremely difficult forecast. There was no cold air in place. There was nothing even in northern New England. What we did well was we hit the main areas that got hit with the heavy snow and the power outages, which was the Worcester Hills and into the hills of Northeast Connecticut. The other issue was we didn't know the exact westward extent of the heavy rain or snow. So that was problematic. And given that the temperatures were between 32 and 33, were you going to be dealing with more heavy rain or heavy snow? And each hour you don't have snow makes a difference between, say, having 8 inches of snow and 1 inch of snow, because it could be snowing at 2 inches per hour. So whenever the atmosphere is right on the cusp of rain or snow, it's very challenging for forecasters. And looking at the bigger picture, what might we have done differently? Well, the surface low tracking near Nantucket, that's not usually the good track to get big snows in eastern Massachusetts. That low is too close to the coast. It tends to bring warm air, relatively warm air, I should say, off the Atlantic Ocean. So that was a big factor in this. The high resolution models were really onto the heavy snow in eastern Massachusetts despite that. But the surface observations were never able to get below 2 or 3 miles. And that's usually a telltale sign that things are not evolving as, we had anticipated. So it's definitely tough to sometimes ignore the model guidance. There's so much things to look at, but kind of keeping in the back of your mind as forecasters, the overall pattern. Does this pattern support heavy snow? Does it support heavy rain? What are you thinking? And that's leading into what Rodney's going to talk about with the upcoming forecast. What pieces are there? What pieces aren't there? What's the most likely scenario? What could go wrong?